capacitor, parallel plate capacitor. What all we discussed will be for parallel plate. So this is the switch. This is the EMF of cell. This is having a capacitance C. Now potentials of plate, EMF, this is a terminal voltage, and these are plate X and Y, I'll call it. I'll close the switch. So here, if let's say that E equal to some EMF is there. So what is VAB? VAB should be equal to E. Now after closing switch, what will happen? There's no charge initially. There's a no charge. Better say uncharged capacitor. So after closing switch, what conditions will arise? Now look at this one. So potential of plate X and Y initially is 0 because there is no charge in it. And VA greater than VB. Now the moment I close switch, so definitely what do we expect here? No? Potential of plate A greater than potential of X. So therefore what will happen to charge? Charge what happen? Will flow from high to lower potential. So from here it's very clear VA greater than Vx. So the positive charge will leave the positive terminal of a cell and will enter here. And with this what happen? It will get deposited. A positive charge will get deposited here. This will induce a negative charge. And again, what happen? The positive charge will be attracted by the negative terminal because charge of a cell must be conserved. And this is what happens. How long this flow of charge will occur? So first what will happen? As VA greater than Vx, the charge starts flowing here.
Sir, why is Earth, sir? Sir, why is Earth, sir?
Can you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then yeah, I'll continue then. Now why charge will flow from the cell? Because charge will flow from high to lower potential. There was no charge initially across capacitor. There was no charge. So the here open the charge because of electromotive force, the charge will pass through like this. So it will enter now. It will get deposited on the plate X. This will induce a charge minus Q, and this plus Q what happen will flow like this. So like this continuously, charge on capacitor will keep on increase. No, the charge here will become plus Q, here minus Q. How long this will take place? Next question comes. So as the charge on this plate will keep on increase. If Q increases, definitely what happened to E? The E must increase. As E increases, potential Vxy will also increase. So with the time, so here what is the reason why charge flows? Because Va greater than Vx and Vy greater than Vb. This is what happens. That's why there's a flow of charge. And if you calculate Vxy, it will be less than Vab or applied EMF. How long this flow of charge will occur? As long as Vxy greater than applied EMF. Finally, what will happen? There's a best initially this one. So everywhere what happen, you have to trace out the charge. There it was the current, no? Here it's about the charge. Finally, what will happen is this is the applied EMF. This is a plate A, plate B. This is X, this is Y. The charge here will be plus Q. And further, there won't be any drifting of charges. So now what will happen is finally, VA will become equal to Vx, VB equal to Vy, and VAB equal to Vxy equal to applied EMF. No more flow of charge, it's over. And now come and check it, the electrostatic field. So here it was E dash, and the field will be E. Okay, got this one. So let's calculate energy in capacitor. So what is the C? C is the capacitance of this capacitor. So what is the expression for energy in capacitor? Energy in capacitor, or energy stored in capacitor, better you say like a stored. I'll use symbol U. This should be equal to how much? Q square by 2C. We don't know value of Q. What is Q actually? From this diagram, what is Q is equal to? Q equal to Vxy into C. Charge equal potential difference. What is potential difference? EC. So let me substitute here. EC whole square by 2C. Or you can write E square by 2C. Because what are known things? The applied EMF and the capacitance. So in terms of that, I brought it.
E square C
What
by
is
2, sir.
work done by the cell? Correct, no?
C in numerator, sir.
C square by 2. Now, from where this energy in capacitance come? The cell only should do work. What is work done by a cell? If a positive charge leaves positive terminal, the work done. So how much of charge actually flown? Plus Q charge. And like this, you show the flow of charge. So what is the total charge left positive terminal? This one. So you go back to current intensity. If a current leaves positive terminal, the battery supplies energy, no? Similarly, if a charge leaves positive terminal of a cell, then the battery is supplying work, or battery is supplying energy to the circuit. So work done by the cell. Work done should be equal to how much? Work done by the cell should be equal to Q into Y positive, because positive charge leaves positive terminal. And what is Q is equal to CE. Look at this. The cell does work CE square. Half of it will go in capacitor. The remaining of where it should go. Remaining of where it should go. It should be converted into heat. So therefore, work done by a cell should be equal to energy stored in capacitor plus heat generated in circuit. This one. So what is this? This is we write like this. So substituting all the values, they should be. This is C. This much will be heat generated in the circuit, half of it. So now you tell me like, I want to store 10 joules of energy in capacitors. How much of work the battery should do? 20 joules it should do. And the remaining 10 joules will be lost as heat. 10 will be stored in capacitor. The remaining 10 will be lost as heat permanently. Heat generated where? In the connecting wires. So this is the basic idea. Now already charged capacitor, if I connect, what conditions will arise?